All right, so now we're supposed to identify the indeterminate form of each. So remember, the indeterminate form is 0 over 0, infinity over infinity, or 0 times infinity, which then we have to make into one of those kind of things. And then we're going to use L'Hopital's rule to evaluate the limit of any indeterminate. All right, so what do we do? Well, first, what we're going to have to do is we're going to have to plug in 1 and see what we get. Well, if we do that, we have ln of 1 over 1 minus 1. Well, ln of 1 we said was 0. 1 minus 1 is 0. So that's our indeterminate form. Okay. So what we need to do then is switch this up and take the derivative of the numerator over the derivative of the denominator. So that's going to be limit as x approaches 1 of ln of x derivative is 1 over x. N minus 1 derivative, well, that's 1. Okay. Well, now we just plug in x is 1, so that gives us 1 over 1 divided by 1. Well, that just gives us 1. So that then becomes our limit as x approaches 1 of ln of x over n minus 1. Okay, what about our next one? Well, the next one, if we plug in 1 here, 1 minus 1, 1 minus 1, and so that's going to be 0 over 0 is our indeterminate form. Okay, so because 1 to the fourth is still 1, so 1 minus 1 is 0, and 1 to the third is 1, minus 1 is 0. So what we're going to have to do is take limit as x approaches 1 of, now taking the derivative of that, that's equal to 4, not equal to there, but it's over, 4x to the third, and that one is going to be 3x squared. Now, if we plug in 1, what does that give us? Well, 4 times 1 over 3 times 1. Well, that's 4 over 3. Well, that's the number we can use, and so that is going to be our limit. Okay, so we started off with the 0 over 0. We took our derivative, and then we ended up with 4 over 3 as our final value. Now let's go ahead and do some more. So here we're supposed to evaluate the limit. If the limit is of an indeterminate form, indicate the form and then use L'Hopital rule to evaluate. So our first thing is to always test and see if we can plug in 2. So 3 times 2 minus 6 over 2 plus 2. Well, that's going to be 6 minus 6 is 0 over 4. All right. So 0 over 4 is not, 0 over 0 or infinity over infinity or 0 times infinity. So it's not indeterminate. So that's just 0. So that's going to be our limit. Okay. All right, what about this next one? All right, so this one looks a little more complex. So if we plug in our values, we're going to have 5 minus 1 to the 1 half minus 2 over 5 squared minus 25. Well, this is looking to be like it's going to be 0 over 0 because 5 minus 1 is 4, square root of 4 is 2, so 2 minus 2 over 25 minus 25, well, that's 0 over 0. Okay, so that's our indeterminate form. Okay, so what are we going to do? Well, we're going to have to take our derivatives. And so, if we think about the denominator is easy. So that's a limit as x approaches 5 of 2x. Okay. Now, this one, if we call that the inside function and then to that power, you know, the inside function is going to end up with a 1. And so it's going to be a 1, and then we're bringing down the 5. So it's going to be a 0.5, and then it's going to be times the x minus 1 to the negative 1 half. Okay. So remember, that's going to be kind of our, if u is equal to x minus 1, and then it's going to be du is equal to, well, that's not going to be du, but it's going to be if this is maybe g of u is equal to that, and d of g is going to be the u to the 1 half, then it's going to bring down 1 half u to the negative 1 half, which is that part. Derivative that's 1, and so we just have that 1 half times x to minus x minus 1 to the negative 1 half. So it all comes from there because that just gives us 1 when we take that derivative. All right, so now what we have to do is we have to think about plugging in our values. And so if we plug in 5, that's going to equal 0.5 times 5 minus 1 to the negative 1 half all over 2 times 5. And so that's going to give us 0.5. And this really we can take to the denominator. And so we'll have 10 times the square root of 4. And so that's going to be equal to 1 half times 1 over 20. And so that's going to give us 1 over 40, which is equal to 0.025. Okay, so then that would be our final answer. And this is a 20 here. It's kind of hard to read. Okay, so it's 2 times 10 is 20. That's a half, so I just wrote it as a half. And then multiplying all that together, we get the 0.025. And then that would be our actual limit of this whole thing. So we had to do that inside-outside function to take that derivative. That one was just 2x, and then plug in our values along the way, and we get our answer. Okay, what about this one? Well, if we plug in 2, that'd be 2 times 2 squared minus 5 times 2 plus 2 over 5 times 2 squared minus 7 times 2 minus 6. Well, if we plug that into our calculator, we get 2 times 4 minus 10 plus 2. Well, that's 0. And then on the denominator, we have 5 times 4 minus 14 minus 6. And let's see. Wait a second here. I did something wrong here. Oh, I took 5 divided by 4, not 5 times 4. And that's 0 as well. And so we get the indeterminate form. So now what we have to do is we have to take the limit of our derivatives. And so that's going to give us what? 4x minus 5 over, and that's going to be 10x minus 7. Okay. Now, what do we get if we plug in 2? Well, that's going to be 4 times 2 minus 5 over 10 times 2 minus 7. So that's going to be 8 minus 5, so that's going to give us a 3. That's going to be 20 minus 7 is 13. And so that's not an indeterminate form, and so we would be done, and that would be our limit of our original value. Of course, we did it through L'Hopital's rule, but that's how we got it. Okay. What about the next one? Okay, well, the next one we're going to do just the same way, except we're going to think about this. If we do this, we're going to have 3 times some huge infinity to the fourth over 5 times infinity to the third plus 6. Well, what's that going to give us? Well, that's just going to be infinity over infinity. Well, that's going to be our indeterminate form. Okay. Now we haven't had one of those yet, but that's one of the possibilities. We've done 0 over 0 a lot, it seems like. So this is our first one like this. Well, what do? Well, we're going to take the limit as x approaches infinity of the derivative. Well, that's going to be 12x to the third over 15x squared. Okay. Well, that's not too bad. What does that give us? Well, that's going to give us, again, infinity over infinity. Okay. Well, but can we do anything before we do that? Let's look here. Because if we just look at it that way, that's what it is. But can we cancel? That's going to be a key thing. So, going right away, we're like, well, that's just infinity over infinity. But you also have to think about reducing. Well, 3 will go in here, 4. 3 will go in here, 5. 2 of those cancel 2 of those, and we get x. And so then what does that give us? Well, that gives us 4/5 times infinity instead of infinity over infinity. And so then that is still infinity, but it's not the, 0 over 0. It's not the infinity over infinity, and it's not 0 times infinity. And so therefore, that would be our final thing. So sometimes, rushing through and saying, oh, well, it's just infinity over infinity. I don't know what to do now. You think, oh, wait a minute, I need to reduce this. So that gives me that reduction. I can reduce those cancel. And so then I have and it's really actually going to be the limit as x approaches infinity of that. And so when we do that, that's when we get to infinity. So what we're doing is reducing what's inside the limit first, our cancellation rule. And then from there, when we take that and plug in the infinity, we just get our infinity. All right, so let's stop there and we'll be back.